Okay, so this video is just a series of questions that I would work through with students during class time, and since you're an online student, I've gone ahead and made a recording of what I would be talking about. The best advice I can give you here is that you treat this as though you were in class, and so you participate in the exercises and you stop the video before I get to the answers, and make sure that you actually do the mental work so that when you get to the answers they make sense, or if they don't make sense, that you can stop and maybe go to the questions discussion board and ask me a question. So the first thing that I would do with students in Chapter 1 is work on vocabulary, because there is a bunch of new terms that show up in Chapter 1, and some of them you might have seen before and some you might not. So take a moment, stop the video, and check your notes. Do you have a definition for each of these terms? If you don't, go to the textbook and find out what it should be and put it in your notes, and then start this back up and I'll walk you through the definitions that I think are important for you to know. Okay, so the first thing here is an element, and the element and the compound are both examples of pure substances. So I'm going to put this over here so we keep that in mind. An element is the simplest form for a pure substance. It only contains one type of atom. Whoops, my pen just stopped working. And if you chemically break it down, you might be able to break a bond if you had a molecule of an element, which might not make any sense to you right now, but that's okay. So just keep in mind, it's the simplest form, only contains one type of atom. It's a pure substance, so it only has one set of properties. A compound, also a pure substance as we noted, contains two or more types of atoms. That's different than an element, which only contained one type of atom. And those two types of atoms are chemically bonded together. And chemically bonded might not feel like it makes a lot of sense right now. You can think about this as like a special type of glue and super glue, actually. And it's so fantastic that you would have to put a lot of energy in to get these atoms to separate from each other. So they act like a unit. They're chemically bonded, and they also have only one set of properties. And the thing that I remind students of here is to think about something like water, H2O. It's got H's, which are hydrogens, and it's got oxygen, which is the O. And when you think about what you know about water, you know that it boils at 100 degrees Celsius and not something else, right? It just has one boiling point. So it just has one set of physical and chemical properties. You can break a compound down. So you can decompose a compound using chemical means. I should stop here and say, if you haven't watched the short video lectures or the long video lectures, that's where you would really want to start here. This exercise in this video is really assuming that you've already got some base knowledge, and now we're going to start applying it. So these terms should not be completely, totally new to you. Homogeneous mixture. These are different than homogeneous mixtures, and heterogeneous mixtures are different than elements and compounds because they have to have two or more substances. So elements and compounds were pure substances, homogeneous mixtures and heterogeneous mixtures. The key word there is mixture. They have two or more substances. Now, those two or more substances are physically combined, which means I can separate them using physical means. And that's the general definition of a mixture, is two or more substances that can be separated using physical means. And that means that there are two or more sets of physical and chemical properties when we look at a mixture. The difference between homogeneous and heterogeneous is homogeneous mixtures are one visible phase, and heterogeneous mixtures are two or more visible phases. So you should have more in your notes there based on what I just said, but I don't have room to write it down. So two or more substances, they keep their own individual properties. So when we have a mixture, we should be seeing more than one set of physical and chemical properties. Physical changes and chemical changes or properties, these are things that tell us about the identity of what we're looking at. So physical changes, the key thing to recognize here is that these are reversible. So to know that something's a physical change or a physical property, you can observe the property, or you can cause the substance to undergo the change and you still have the same substance. So for instance, when you melt an ice cube, you started with an ice cube, which is solid water, and you end with liquid water. It's still water. You just change the physical state of it. Chemical changes and chemical properties, on the other hand, are not reversible. These result in a change in identity because you've broken some chemical bonds or you've made some new chemical bonds. Broken or made bonds. Okay, then we have liquid, solid, and gas. The thing to think about here is whether you have a defined volume and whether you have a defined shape. So solids have defined volume and shape. Liquids have a defined volume, but an indefined shape, indefinite. And you can think about that in the sense that if I have some water in a cup and I pour the water out of the cup, I don't have a cup-shaped thing of water. I have water all over the place. Versus a solid, if you have an ice cube and you put it in the cup, it's still the ice cube shape, regardless of the fact you took it out of the freezer and put it in the cup. Gases have indefinite shape and volume. So they take the shape of their container, and that's the indefinite shape part, and they're compressible, which is where the indefinite volume comes into play. Then we have a molecule and an atom, and a molecule is two or more atoms chemically bonded, while an atom is just the simplest form of an element. And in chapter 3, you'll learn more about what an atom's actually made of. So if I wanted to draw a picture, I would say that a molecule might look like this, and an atom would look like that. Okay, moving on to the next slide. So, how do you know a substance has a definite volume, has a definite shape, and then here's this tire, it's filled with gas, and we put a hole in it. It's punctured. Does the volume of the gas increase, decrease, or stay constant? Take a moment, stop the video, write down your answers, and then restart it when you're ready. So we know that a substance has a definite volume because it can't be compressed or expanded. So it keeps its volume regardless of whether we try and squish it closer together or not. A substance has a definite shape when it keeps its shape regardless of what container we put it in. And a tire is filled with gas and it's punctured. What happens is that gas was contained in this original volume of the tire, but when you put a hole in it, you hear that sound, that psst of the gas escaping. So the gas isn't just in the tire anymore, it's both in the tire and in the surroundings. And we know that gases can expand, and that's actually what's happening. You've taken a compressed gas and you've opened its container, and so the inside gas is expanding. And so the volume of the gas is increasing because your gas is expanding to fill the new container, which is outside. Okay. On this slide, you need to classify each of the following as a chemical or a physical change. So for instance, I'm going to do number 1 for you. Here we are with number 1. I start with this. And each of these triangles, so the triangle represents one thing. If 2 triangles are touching, it tells me I have a bond. So if things are touching, it tells me I have a bond. And circles are going to be used to represent something that's not a triangle, so a different type of atom. So I've got a circle type of atom and I've got a triangle type of atom, and if I put them together, then I have a bond. So when I look at number 1, I have 2 triangles. So I have 2 atoms of the same type and they're connected. So that tells me that I have a molecule. And I can see that I take that molecule, and as I go from before to after, now I have 2 triangles and they're separate from one another. See, there's one, there's one. So the bond that I had here is no longer present. And if you think about the definition of chemical and physical changes, chemical changes involve a change in identity. And that means I've broken or made new bonds. So in number 1, I broke a bond, and so we would classify this as chemical. So now you should stop the video and do number 2 and number 3 and number 4, and then start it back up when you're ready. So in number 2, I have 2 types of bonds. Or excuse me, I only have 1 type of bond. I have a circle triangle bond here, and I have another circle triangle bond there. Over here, I have a triangle triangle bond and only 1 circle triangle bond. And so that tells me that I broke a bond. And actually I made a completely new one because I made the triangle triangle bond. So this involves a change in identity. I've broken bonds and I've made bonds, and so this would be considered chemical. Would be considered a chemical change. Sorry. In number 3, I start with a circle triangle bond and a triangle by itself, and I end with a circle triangle bond and a triangle by itself, and so nothing actually happened here. At least nothing chemical. So you could say physical or you could say nothing happened. Either of those would be fine. I'm going to say physical, just because that was the only other choice that I gave you. In number 4, we have a triangle-triangle bond and a triangle-triangle bond. And it tells me that I start with something that's compressible and it takes the shape of its container. And then I end with something with defined shape and defined volume. And this definition is telling me that I start with a gas. And this definition is telling me that I end with a solid. I combine that with the fact that I didn't make or break any new bonds, and this is simply a physical change. Okay, next slide. So now we're going to go back to that same slide and identify whether we're looking at an element, a compound, and also whether it's an atom or a molecule. So each substance should have 2 labels, either an element or a compound, and an atom or a molecule. So you can go back and look at that for a moment, stop the video, and then I will walk you through when you're all finished. Do some erasing while you work. Okay, so in number 1, you may have caught that I mentioned that this was a molecule and that it's a molecule of an element, because in order to be a compound, you have to have 2 different types of atoms. I only have 1. Afterwards, I still have an element, but now I have 2 atoms. In number 2, I have a molecule because I have 2 or more atoms bonded together, but this time I have circles and I have triangles, which tells me this is a compound because I have two different types of atoms. And the same thing happens on the other side. Again, it's molecule and compound. In number 3, I have this guy here, which is a triangle and a circle, so this is a molecule, and it's also a compound. And then we already identified this up here as an element and an atom, and nothing happened over here, so we should have the same answer. And then in number 4, we already talked about this guy up here. Okay, are the following chemical or physical changes? Take a moment and classify each. Okay, digestion is a chemical change. We don't eat our poop, pretty much. So this is chemical. Boiling water, when you boil water, you make steam. It's still water. It's just water as a gas. So this is physical. And if you think about it, we can reverse that process because we can collect the steam and condense it back down to make water. Burning marshmallow is definitely chemical. You have changed the chemical identity of the marshmallow once you've burnt it. That black stuff is no longer your nice puffy marshmallow. Hammering a nail, we haven't actually done anything to the nail except maybe compress it a little bit. So this is physical. We still have a nail. Okay, classify each of the following as an element, compound, homogeneous mixture, or heterogeneous mixture. And again, each shape represents a particular type of atom. So stop the video, think about 1 through 4, identify whether they're an element, compound, or homogeneous or heterogeneous mixture, and then start the video back up when you have your answers figured out. For number 1, I have 3 types of the same atom, here and here and here, and they are chemically bonded together. So when I think about my choices, this is definitely not a mixture, because in order to be a mixture, I'd have to have 2 or more pure substances. I only have 1. And it's not a compound, because to have a compound, I have to have 2 or more types of atoms, and I only have 1. So this is an element. In number 2, this should look somewhat familiar from a couple slides back. This has a circle and a triangle, which tells me, and they're chemically bonded together. So it's not an element. And it's also not a mixture because I only have 1 type of substance. I'm only looking at 1 molecule there. I happen to see that it has 2 different types of atoms, which helps me to identify that this is a compound. In number 3, I have 3 separate atoms, and I notice that they're all the same type. They're all triangles. So even though these are all separate from one another, it's still just the same thing, and this is an element. In number 4, I have 2 types of things. I have circles and I have triangles, and they're not chemically bonded together. They're not touching each other. So that tells me that what I'm looking at is a mixture, and I can see, because it's drawn, so I can see it, that I've got circles and triangles, so this would be a heterogeneous mixture. So before you get concerned about the fact that, hey, what's the circle triangle stuff, and I'm not sure I totally understand it, keep in mind you do have the video lectures to go to, and that an actual quiz question wouldn't involve circles and triangles. It's going to look something more like this. Classify substances A through D as elements, compounds, heterogeneous mixtures, or homogeneous mixtures, and identify any chemical or physical changes. So substance A is a clear liquid with red chunks floating in it. We want to identify what that clear liquid with red chunks is. That's A. The red chunks, which are B, are filtered off of the clear liquid, which is C. The red chunks are heated and observed to melt completely at 200 degrees Celsius. Further heating causes no further changes. The clear liquid C is heated and observed to boil at 35 degrees Celsius and again at 170 degrees Celsius. The liquid that boils at 170 degrees Celsius is substance D, and it's composed of a homoatomic molecule. Take a moment. Grab your notes on elements, compounds, homogeneous mixtures, and heterogeneous mixtures, and see if you can identify what A, B, C, and D are. Stop the video, Start it back up when you're finished. So substance A is a clear liquid with red chunks floating in it, which tells us we can see two things. We can see the clear liquid and we can see the red chunks. So hopefully you recognized, hey, I can see two things. A must be a heterogeneous mixture. And those two things were clearly different. Sometimes heterogeneous mixtures, sorry, I don't want to go down that road. We'll just stop there. With heterogeneous mixture, we can see that there's two different things. Then we have these red chunks, and it tells us that the red chunks are heated and they melt completely at one temperature. And that's giving me some hints. It's telling me that I only have one substance present, which means that B cannot be a homogeneous mixture or a heterogeneous mixture. Only one melting point means only one substance. The question is, do I have an element or a compound? And then I go to this next sentence, which says further heating causes no further changes. If this was a compound and I heated it, eventually I would have enough energy in there to break the chemical bonds of a compound. But I didn't see any further changes. So that tells me it's not a compound, that it's an element. So B is an element. The clear liquid C is heated and observed to boil at 35 degrees C and again at 170. So this clear liquid has two boiling points, which is telling me there's more than one substance in there. This can't be an element or a compound because they would only have one boiling point. It also tells me that I'm looking at a clear liquid. So not a clear liquid with stuff in it, but just one visible phase. So the fact that there's two boiling points and only one visible phase tells me that C is a homogeneous mixture. D is composed of a homoatomic molecule. Homoatomic means same type of atom. So this is something like our 2 triangle or 3 triangle molecule, and that must be an element.